The following is a table that includes the function and antiderivative of that function. In the book, they use the notation f prime equals f and g prime equals g. We should note that to get the most general antiderivative from ones like in this table, we have to add a constant like we did in example 1. So for example, it would be like e to the x plus c would be the particular antiderivative of the function e to the x. I'll give a second for it to write it down. Okay. So we should also note that we often use a capital letter F to represent an antiderivative of a function f. If we were to begin with a derivative notation, f prime, an antiderivative is f.
Now, for example 2, we are going to find all functions g such that g prime x equals 4 sine of x plus 2x to the fifth minus square root x all over x. So we can rewrite this as g of x equals 4 sine x plus 2x to the fifth over x minus square root x over x. Now we can cancel some of these, and we would get 4, I'll let you write for a sec, 4 sine x plus 2x to the fourth minus 1 over square root x. Now, again, to simplify and rewrite, we write g prime of x equals 4 sine of x plus 2x to the fourth minus x to the negative 1/2. So using the table or your knowledge of the antiderivatives, we then can solve for g of x. And we do that. G of x equals, we did sine of x earlier, so it'd be 4 times negative cosine of x plus, using the x to the n plus 1 over n plus 1, we can get 2 times x 4 plus 1 over 4 plus 1 minus, doing the same thing for this one, x negative 1/2 plus 1 over negative 1/2 plus 1. Now, to rewrite this and simplify it to get the final, we do g of x equals negative 4 cosine x plus 2 over 5 x to the fifth minus 2 square root x plus c. Don't forget the c.
So, moving on, a differential equation is an equation that involves the derivatives of a function, and the general solution of this involves an arbitrary constant or constants, like in example 2. However, there may be some extra conditions given that will determine the constants and therefore uniquely specify the solution. We'll move on to example 3.
Find f if f prime of x equals e to the x plus 20 times 1 plus x squared to the negative 1. We need the general antiderivative, and we can start by rewriting this as f of x equals e to the x plus 20 over 1 plus x squared, which can also be rewritten as e to the x plus 20 times 1 over 1 plus x squared, which then we can now take the antiderivative, and we should see that this looks familiar, and e to the x is always e to the x. So if we do that, we get f of x equals e to the x plus 20 times the inverse of tan to the x plus c. Don't forget the c. If f of x, f prime of x equals e to the x plus 20, 1 plus x squared minus 1, if f of 0 equals negative 2. So we already solved for this part of it. Now, to find c, all we have to do is plug in 0 and set it equal to negative 2. So we can do f of 0 equals e to the 0 plus 20 times inverse tan to the 0 plus c equal to negative 2. Now e to the 0 is 1 plus inverse tan of 0 is 0, because when you think of the unit circle, it's 0, times 20, 0 times a number is 0. So you get 0 plus c equals negative 2. Now we need to get c alone, which means c equals negative 3. Now, to get the final equation, we should plug it back in. So we get f of x equals e to the x plus 20 times tan inverse of x minus 3.
So in relation to example 3, this figure shows the graph of the function we just solved and its antiderivative. So we note that when f prime of x is greater than 0, f is always increasing. And when f prime of x has a max or min, f has an inflection point. The purpose of the figure is to mostly check on our calculations.